Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0985 refers to a problem specifically with the Shift Solenoid Valve E in the Honda CRV models from 2011 to 2016. This error indicates a short circuit in the electrical circuit associated with this solenoid, which is fundamental for controlling transmission shifts. Understanding this DTC is crucial for diagnosing transmission issues, since this error is purely electrical and not related to any mechanical malfunctions within the transmission. The Shift Solenoid Valve E is responsible for regulating fluid flow in the transmission as per the demands of the vehicle's operation, crucial for proper gear shifting. When this DTC appears, it prompts a series of diagnostic checks using the Honda Diagnostic System, HDS, to isolate the source of the electrical fault. Special attention must be paid to the wiring, connections, and the valve itself to determine the root cause of the short circuit problem. The primary component affected by DTC P0985 is the Shift Solenoid Valve E, which plays a crucial role in the automatic transmission system. This solenoid is responsible for controlling the hydraulic flow in the transmission mechanism, enabling smooth gear changes and optimizing engine performance. Its operation directly influences the vehicle's ability to shift effortlessly, thereby affecting the overall driving experience. The Shift Solenoid Valve E is typically located within the transmission assembly, connected via a wiring harness to the powertrain control module, PCM. The solenoid communicates with various sensors and other components in the transmission to ensure accurate fluid pressure management and responsive gear shifts. When the HDS indicates this DTC, it reflects actions available to the car. It points to a malfunction in the electrical circuit rather than any mechanical failure within the solenoid or transmission assembly. DTC P0985 can arise from several potential causes, which, if not thoroughly investigated, can complicate the repair process. The most common cause is an electrical circuit malfunction, which involves improper connections or shorts within the wiring harness linked to Shift Solenoid Valve E. This can manifest as damaged wires due to wear and tear, or exposure to heat and movement, impairing the solenoid's function. Additionally, defective wiring, particularly a short circuit to ground in the harness leading to the powertrain control module, PCM, may trigger this DTC. It's also pertinent to consider that the shift solenoid itself might be faulty, although this is less common when the DTC indicates a circuit-related issue. A systematic approach to diagnostics is essential to isolate the exact problem in this scenario. When DTC P0985 is present, drivers may experience a variety of symptoms related to transmission performance. One of the most noticeable signs is difficulty in shifting between gears, which can lead to erratic or stuck gear changes. Such shifting issues may manifest as delayed shifts, over-revving, or being unable to shift into certain gears entirely. Additionally, the vehicle may have warning lights illuminated on the dashboard, typically the check engine light, which indicates that the onboard diagnostic system has detected a fault in the vehicle's performance. These symptoms not only affect driving comfort and control, but can also lead to more significant transmission damage if not addressed promptly. It's crucial to recognize these symptoms as indications that further diagnostic procedures are needed. The first step in troubleshooting DTC P0985 involves initiating a detailed DTC check using the Honda Diagnostic System, HDS. Begin by turning the ignition switch to the on position second without starting the engine. This enables the onboard systems for diagnostic purposes. Next, clear any existing DTCs from the system using the HDS to reset the fault codes. This step is essential as it allows for the verification of any new or persistent issues that may appear after clearing. After clearing, start the engine and ensure the shift lever is in the Park P position. Then wait for at least 1 second to allow the system to stabilize. Finally, check for any pending or confirmed DTCs using the HDS. If DTC P0985 is indicated, this confirms that the failure has been replicated, and the troubleshooting should proceed to the next step. The second troubleshooting step involves checking the operational status of Shift Solenoid Valve E via the Honda Diagnostic System, HDS. Access the miscellaneous test menu within the HDS and specifically select the Shift Solenoid Valve E for testing. During this test, you should listen carefully for a clicking sound, which indicates that the solenoid is functioning correctly. If a clicking sound is heard, it confirms that the shift solenoid is operational, suggesting that the electronic command from the PCM to the valve is effective. In this case, progress to the next step in the troubleshooting process. On the other hand, if no clicking sound is detected, it suggests an issue with the solenoid's operation, requiring further investigation into the solenoid or its wiring before proceeding. In the third step, begin by starting the engine with the shift lever still in Park P position, waiting at least 1 second for system stabilization. Access the OBD status through the HDS, monitoring the status of DTC P0985 in the DTCs menu. If the HDS indicates a failed status, this confirms the problem persists and further diagnostics are needed. The next step involves inspecting for poor connections or loose terminals in the wiring between Shift Solenoid Valve E and PCM. Must be checked thoroughly. If the HDS indicates passed, it means the failure might be intermittent, and you should proceed to check for an intermittent short to ground in the wiring. Should the HDS indicate not completed, retest the vehicle following an appropriate drive cycle for more accurate diagnostics. The fourth step focuses on performing an internal resistance check on the Shift Solenoid Valve E. Start by turning the ignition switch to the lock position. This step is essential for ensuring safety while working on electrical components. Next, jump the SCS line using the HDS, which temporarily disables the SCS system to allow for testing. Disconnect the PCM connector B49P carefully to prevent any damage or misalignment. With the connector removed, measure the resistance between the designated test points. Test point 1 is located at PCM connector B49P number 40, which is the yellow wire, and test point 2 is body ground. The acceptable resistance should be less than 13.8 ohms. If the measurement is within this limit, proceed to the next step for possible repairs. If the reading is above this threshold, it indicates an issue that warrants further investigation of the internal resistance of the solenoid. In the fifth step, the focus shifts to checking for shorted wires in the system. Begin by disconnecting the Shift Solenoid Wire Harness 8P connector to isolate the circuit. After disconnection, check for continuity between test point 1, located at PCM connector B49P number 40, and test point 2, which should be body ground. This diagnostic procedure is crucial in identifying any shorts to ground that could be affecting the operation of the Shift Solenoid Valve E. If continuity is found, this indicates a short to ground, necessitating repairs to the SHE yellow wire between the Shift Solenoid Wire Harness and the PCM. Following repairs, a verification check must be conducted to ensure the fault is resolved. If no continuity exists, it suggests that the SHE wire is intact, and further testing should continue with the next troubleshooting step. The sixth step is focused on testing the performance of Shift Solenoid Valve E directly. At this stage, you need to conduct a test to determine if the solenoid itself is functioning optimally. If the valve operates correctly and meets the functional standards, it can be considered okay, and the next step would involve replacing the Shift solenoid wire harness, then conducting a repair verification to ensure the fault has been rectified. Conversely, if the solenoid valve does not operate properly, it requires replacement to ensure the transmission system functions as intended. In either case, it's critical to thoroughly check wiring and connections to confirm there are no additional underlying issues that could again trigger DTC P0985 in the future. After performing necessary repairs related to DTC P0985, it is critical to conduct a final verification to ensure that the issue has been fully resolved. Begin by reconnecting all previously disconnected connectors to restore full electrical functionality to the system. Once all connections are secure, turn the ignition switch to the on position, second stage, and proceed to clear the DTCs using the Honda Diagnostic System, HDS. This step is vital for resetting the system and allowing for an accurate assessment of the vehicle's status post-repair. Start the engine with the shift lever in Park P, waiting for at least 1 second, then shift it to neutral, N, and again wait for 1 second. Finally, monitor the OBD status for DTC P0985 in the HDS. If the status indicates passed, the troubleshooting is complete. However, if it shows failed or not completed, further investigation is required. Implementing preventive maintenance is crucial in avoiding the recurrence of DTC P0985 in Honda CRV models. A fundamental step is to regularly inspect the wiring associated with the Shift Solenoid Valve E, ensuring there are no frays, corrosion, or other damage due to environmental exposure or wear and tear. Updating the PCM software is another preventive measure that can ensure the vehicle's electronic systems operate efficiently and reliably. Additionally, routinely checking for loose connections will help in maintaining electrical integrity, reducing the chances of intermittent faults that can lead to error codes. It's recommended to document all maintenance activities, providing a clear history that can assist in future diagnostic efforts. In conclusion, DTC P0985 is indicative of an electrical issue concerning the Shift Solenoid Valve E in Honda CRV vehicles from 2011 to 2016. Understanding that this DTC points to electrical circuit problems rather than mechanical failures in the transmission is essential for effective troubleshooting. Employing a structured diagnostic approach using tools like the Honda Diagnostic System, HDS, ensures accurate identification of the fault source. Timely repairs following these diagnostics are crucial to preventing further damage to the transmission system, which can incur costly repairs. Adhering to preventive maintenance guidelines will help maintain the vehicle's performance and reliability, ensuring a smoother driving experience and aiding long-term ownership satisfaction. Please like and subscribe to the channel. See you next time.